Hello everyone, today I'm going to be talking about search algorithms. So yeah, let's get into it. First, we're going to be talking about what is a search algorithm, and then what is a linear search, what is a binary search, and then linear versus binary search comparison. So what is a search algorithm? A search algorithm is an algorithm which will find an item in a given list. We have search algorithms that should be built to be as efficient and effective as possible. By this, we mean, when we say efficiency, we mean it should complete quickly, and effective means it should find the result every time. So if we have apple, pear, orange, mango, and kiwi, and we're looking for orange, we can find it and it will return the third item, or it might just return saying that our item is there. So what is linear search? Linear search involves going through all the items list one by one. So if we have apple, pear, orange, mango, kiwi, we will go apple, pear, orange, mango, kiwi. But because we're looking for orange, we go apple, pear, orange, and then it's there. That's the first item. So linear search is very easy to implement and is best for smaller lists, because if we use larger lists, then we need to go through a lot more items before we are going to find our item. So here's an example. If we have the item of orange and we have the index set to 0, then we can say for I in items of apple, pear, orange, mango, kiwi, we're going to print the if the item that we have is the item, we're going to print the index that we have out, and then otherwise we're just going to increase the index by 1. So in this case, if we had our item as apple, which we don't, but it would just go straight to printing the index of 0. But if we have orange, it's going to do apple, then it's going to add 1. Pear, add 1, so we're at 2. And then we can see the second item, or the second index is orange, so we would get the right result. So what's binary search? Binary search is quite different to linear search, and it's often more effective. So it looks for an item in an ordered list. It finds the midpoint and tests a condition. This allows it to remove the sides that do not satisfy the condition. Binary search is harder to implement and is best for large lists. So if we have 6, 16, 36, 46, 64, 96, and 106, that's a lot of 6s, but we're looking for 64. We're going to first go to the midpoint, which is 46, and we're going to say, is 46 greater than 64? And of course that is not true. So we're going to get rid of everything on the left. Because this is a sorted list, we can do that. Then we're going to take the midpoint of that, 64, 96, and 106. So that's 96, and is that greater than 64? And yes, it is. So we can get rid of everything to the right, and including the 96, which leaves us with one result, which is 64. So we know that this does exist in our list. So finally, what is some of the comparisons? Binary search is more efficient in general. Linear search is good for small lists and is easier to implement. But binary search is quite a bit harder to implement. So if we had this data and we're looking for 64, in linear search it takes us 5 iterations to get to the answer, because we go 6, 16, 36, 46, and 64. But binary only takes 3, because we go 46 and then we go to the right of that. So we have 64, 96, and 106. And then we find it's less than 96. So yeah. So yeah, that is it for this video. I hope you found it helpful, and yeah, see you in the next one.